Hey guys, good morning. I hope you had a relaxing weekend and that by now you should have been able to turn in the Chapter 9 review, which I'll be having a look at today and tomorrow. Um, and reach out to me if you still have any remaining questions with that. And we're ready to start Chapter 10, which is conic sections. Now, conic sections, conic is the adjectival form of cone. You might remember that I had that cone in the front of the room on the front desk. I don't know if you'd seen it, but I was going to pull that out when we started this chapter and show you how these graphs, the shapes of these graphs come from a cone shape. And that's why they're called conic section. And it's circles, ellipses, hyperbolas, and parabolas. Now, parabolas we're already pretty familiar with because we actually had a chapter on parabolas in the first semester. We're going to spend most of the chapter looking at circles, ellipses, and hyperbolas. Really, an ellipse, a circle is just a special case of an ellipse where the it has one constant radius rather than like an x radius and a y radius that are different. So today we're really just going to do a little introduction with circles and ellipses. And to do that introduction, first, I want you to take a look at these three problems. If you look at the bottom on page 495 in your textbook, and problems 1, 2, and 3 are what we're going to be looking at today. And they're referring to this graph and this graph up here. And I want you to try them and we're going to go over the answers, but I want to explain what they're asking you to do. So it wants you to plot. That's in your calculator. Now you should have your calculator at home, I think, probably, right? But it wants you to plot this graph, x squared plus y squared equals 1, by solving for y in terms of x. What that means is take this equation, x squared plus y squared equals 1, and isolate the y. So subtract the x squared from both sides, and then you'll notice it says y squared equals, well, you're going to have to take a square root. And that's why here it says enter the two solutions. This is in y1 and in y2 in your calculator. The reason one is a positive and one is a negative root is because you're going to have y squared equals 1 minus x squared from this. And you want it to say y equals, so you have to square root on both sides of the equal sign. And when you take a square root, it's plus and minus. Okay? So see if you can answer that, solve for that one, and get this graph here in your calculator. And then for 2, it wants you to do the same thing. It wants you to isolate the y. So you will subtract 4x squared from both sides, divide by, then you'll have 9y squared equals, you'll divide by 9, you'll take a square root. And what it wants you to, again, show is that with 2 graphs in your calculator, you can get this particular ellipse. Okay, it'll take 2 graphs to make this and this because these are not functions. And you're trying to graph them, you should be in function mode. Radian degree don't matter, yay, because no triangles, right? So no radian or degree does it matter. So see if you can get the 2 equations from here and the 2 equations from number 2 in your calculator. And when you're done with that, when you can see that you have got those 2 equations in your calculator, what I'd like you to do is try problem 3. This is the same equation as this. And what it wants you to do is it wants you to start with this equation, 4x squared plus 9y squared equals 36. And it says by making the right side equal to 1, transform it into this form. Well, there's 2 ways to make the right side equal to 1, and only one's going to work. 2 ways to make 36 become 1 is subtract 35. That's going to just get ugly. Or divide 36. 36 over 36 is 1. So what you can do is divide this term by 36. So you have 4 over 36 x squared. Divide this term by 36. So you have 9 over 36 y squared. 9 over 36 is a fraction you can reduce, right? 4 over 36 is a fraction that you can reduce, right? And 36 over 36 equals 1. So divide this term, where my pointer is, this term, and this term, all by 36 to answer number 3. So I'd like for you to try those 3 problems, 1, 2, and 3 from 496 for today, now that I've explained what I want you to do with them and how they should make this graph for number 1 and this graph for number 2 and 3. We'll go over the answers to those tomorrow to make sure that you know how to do it, okay? Email me if you have any questions and let me know.